I have to go over this one too. More formulas. Whenever you have 2 times an angle, you use double angle formulas. So those 2 are double angle formulas. The sine 2 theta, do I use that one? I've seen this one, cosine 2 theta one, quite a bit in Calc 2. So anybody who's in Calc 2, you should use this enough because you need to see it. They're called double angle formulas. So there's sum formulas and double angle formulas. And anywhere you look on Google, you'll see all of these all at once. Like everybody puts them together. So those are my double angle formulas. I put them up there. Ugh, not again. They give me some information, but not all the information. You know what? I did them. I already know this. You guys need to do this too. When you do them, you're like, ah. When you get to the point, you're like, I know what to do. I'm so bored of doing this. Then you got it, because you're just going through a process and you know what it is. So they gave me the sine. I have the opposite. I have the hypotenuse. I don't have the adjacent. So I'm skipping some steps now because I've done it several times, and I'm getting bored doing it. 3 squared plus adjacent squared is 5 squared. Adjacent squared is 25 minus 9, which is 16. Take the square root of both sides. Adjacent is square root of 16, which is 4. Cosine's less than 0 in the 3rd quadrant. X is between pi and 3 pi over 2. That's pi is at the left edge and 3 pi over 2 is down at the bottom. So 180 degrees and 270 degrees in between those two. That's 3rd quadrant. Their cosine's negative because the x values are negative. So cosine's less than 0. So my cosine x is minus 4/5. Now I can answer the questions that they want. Now I just plug it through those equations. Sine 2x is 2 sine x cosine x. Instead of sine x, I put in they gave me negative 3/5. Instead of cosine x, I put in minus 4/5, and I get 24/25. They match. Oh, that's just showing you where I pulled the information from. Cosine 2x, I run it through the formula again, I get 7/25. And that's where I got the value from to plug in there. Tangent x is sine over cosine, so I take the answer for sine and I put it over cosine, so I'm not deriving anything new. You can probably derive something new, but I'm sick of it. Those cancel out and you get 24/7. All right, no more on these. These are, it's getting kind of like, you get it, it's the same. Let me do, this one's also the same. Half angle formula, so I'm using a different formula. I want to make sure to cover what you need. Okay, so let me do that half angle formula one because you haven't had that. So here they want x over 2's, right? So not double angle, they want half of the angle. So you go back to this list, and these are called half angle formulas. And I also know that sine is positive because they told me x is between pi over 2 to pi. So I can actually see the circle in my mind. Pi over 2 is 90 degrees, pi is 180 degrees, that's the 2nd quadrant. In that 2nd quadrant, y is greater than 0, so sine is greater than 0. So I know that my answer is positive, so I don't need the plus and minus, I just need the plus part. Cosine's negative there, and it's the same old business. Sine x is 6/10. I write it as a fraction so I can extract out the opposite and the hypotenuse. The hypotenuse is the square root of the adjacent squared plus 3 squared. Same old business, I'm solving for the adjacent. The opposite is 3, so I plugged it in. And I got the adjacent is 4. Thank God they were nice numbers this time. So cosine x is minus 4/5. Then sine x over 2, I just plug in all the values where they go. Sine x over 2 is 1 minus cosine. So I plug in where it says cosine, I put in minus 4/5. And run the numbers through and I get 3 over square root of 10. And it matches. That's a relief. Cosine x over 2, I do the same thing. I plug it into this formula. Instead of the cosine, I drop in my answer for cosine, which was minus 4/5. So minus 4/5 goes in. And I run through the numbers, and I get to 1 over square root of 10. tan is sine over cosine. So it's tan of a messy angle, but it doesn't matter. It's messy angle over messy. It's still the same, sine over cosine. So you take the answer for sine and you put it over the answer for cosine. You have a fraction over fraction. Invert the denominator and multiply, slash out the square root of tens, and you're left with 3. So I put all these formulas at the end too, so that you could, I have them within the problems where I use them, so that you can see what I was using where. But I also have them at the end in the PowerPoint, so you could get it off of there if you want to. But I'm telling you, there's so many Google sites that have them. If you just go look up trig identities, almost every page it looks up, you can look at, I don't like that font, I like this font. You can choose what you want to. They're all over the place.